Oh yeah,
Not that much.
yeah. I
No,
lost
so
two hundred
we can't
bucks.
record that for prosperity. I'm sorry.
I know. I lost two
Was
hundred
it
bucks
now?
and realized that I don't like
My
poker
question is
anymore.
though, was it quick?
No, it's
Ouch,
two and
few
a half
hours.
hours.
You got to play for 2.5 hours on
200
not
bucks at a no limit table. It was fun.
okay.
I mean,
That's typical.
I was bored.
No, it's 2.5 hours. Okay, cool. We're on the air for 2.5 hours on. 200 bucks. All right. I just wanted to make sure.
All right, I have to
Now,
open
hold on.
Audacity.
To tweet. Now I say it's from SVP. Say,
Welcome to the pre-show where we get our stuff together.
We say hi to the cat.
Test
think you
1,
have
2.
to-
Hello,
you have
cat.
to leave some time though, right?
Time for what?
Time for what? What a great question.
You have to leave some time for people to.
For your devices? Come on, your devices.
I mean, it's not like
Nice.
anybody's.
The cloud first, mobile first world. With all your devices.
I've been walking around for the past 7 days just saying that in my head.
Oh, did I
Mobile
tweet?
first.
It looks like I tweeted as both. Oh, I'll retweet.
Don't go to this first one. We don't want you to join.
No, I
All
didn't
right.
do that. I just.
Yes. You ready to hit the Audacity record? I guess I should practice.
That's right. Guess I just
Testing
did
1, 2,
Audacity
3.
going.
Testing 1, 2, 3.
And 3.
Wait a second. Wait.
I actually
Oh, no.
think we probably should hit the record button and then say 3, 2, 1, right? So you can get some dead air.
Yeah.
You don't
sure.
believe in that?
I don't believe in dead air. I don't know. I hadn't really noticed the difference when I ran that.
Oh, really?
Yeah, it didn't seem to do anything for me. That's what the professionals do, though, I guess.
No, they did. They did.
Did
They're
they?
like, okay, we're all gonna hold our breath for 5 seconds.
5 seconds?
Mm-hmm. And then I guess they must run some filter. They're like, there it is. That's the important time when we're getting background noise.
Huh. All right, well, let's do it then.
I don't know if it really helps.
Maybe that's why we haven't been getting viewers. Or
Yes.
listeners.
That's it.
Hey, I had like 6 people come up the other day, right? We definitely have
Now,
6
hold
people
on.
from
I
NJNet
need
watching
to-
us.
I need to add a column for. Oh, there it is.
Had to
Oh,
get
we
on.
have a viewer. Hello, viewer.
That was probably me, though.
Oh, we lost a viewer. Oh, another viewer.
I mean, I suppose there could even be.
Oh,
Maybe not.
viewer.
We had a viewer, and then it was gone.
It was
All right,
probably
okay.
me. It was probably me testing that the live stream worked.
We have another one. Now you're just screwing with me.
No, I'm not. I turned it off.
All right, are we ready?
Yes.
Yeah.
Let's do this.
I haven't-
Okay,
record
let's do the dead air then.
Hold on. I gotta.
Let's do
So
the
we're
dead air.
gonna hit record. We're gonna hold our breath, hit record.
Well, I think you hit record, and it doesn't matter if we talk, right?
Yeah, right. We should all. Yeah.
But probably to make it easier to sync up, we hit record at the same time, and then say, okay, now let's hold our breath, and then okay. I don't know if this is gonna work.
What the hell? We give it a try.
Well, so they didn't do like a clap or anything?
No. I didn't record myself either. I thought
Oh,
about
yeah,
I thought about offering, but then I
Right.
went, they seem to know what they're doing.
What'd you do? Just Skype?
Yep, it was just Skype.
Okay.
Well,
All
we
right.
haven't started. Yeah. Well, I mean, I think there's some value in us trying to get the recording
Yeah.
about the same time. Makes it easier to edit, right?
Yes. Right. Let's do 3, 2, 1, and then we'll just give it like 10 seconds, and then I'll break silence. I'll squelch.
All right.
All right. 3, 2, 1, go. All right. Hello, and welcome to the Static Void Podcast. I'm Jess Chadwick,
I'm Todd Snyder.
And I'm Chris Gomez.
and we are your hosts. We are recording this on the evening of April 11th, 2016, and in this episode, we're going to talk about software development patterns. Some people swear by them, and some people call them over-architecting. But still, other people seem to be getting along just fine without even knowing anything about them. So, Chris, I'm going to kick off the show with a question that I ask every potential candidate for my team that I interview. What design patterns do you know and use?
I'll kind of answer that because I have been asked that before, like as an interview question.
Yeah.
And so normally I'll start off and say, well, the strategy pattern is obvious because it decouples the implementation from an interface for your code. So if you need to swap that implementation out, it's pretty easy. And a lot of times, that's often the one that people are looking for.
That's the one I'm looking for. That's my favorite. But everyone, what is the classic answer? What is everyone?
I've actually as I give the answer, one time I was specifically asked, besides singleton, name 3 patterns, and what you would use them for. And I think I pulled out observer, strategy.
Yeah.
To be honest, I don't remember which specific one I might have picked for a third one.
No,
but it's because those are easy to bring out, and observer's built into .NET, so you can always just say that.
Right. But the question that I ask is, what design patterns do you know and use?
Yeah, no, that's good.
Right? So, like, anybody can read the books.
Yeah.
I think the most common design pattern I see is the static design pattern. Make a static class.
Static.
Like a helper class, right?
Yeah,
like,
the helper design pattern.
I don't know really what to do with this, so if I make it a helper class and a static...
Utils, helper,
helpers.
Yeah.
Manager.
Manager.
Factory provider.
So I thought it was interesting, Chris, you mentioned strategy. I think I've asked this question 200 times over the years. And if you get an answer, it is almost always factory or singleton.
Mm-hmm.
I don't think I've ever come across someone who mentioned strategy. You may get someone who says, well, there's creational behavior and structure, but even that is rare. And a little bit of what Jess was talking about, for me when I talk to developers about this, I care more about, do you know the why? Than necessarily, I've used factory or I've used structure. Yep. Like, explain to me, but why did you want, what was the motivation to do this? What was the thought process behind it? Because a lot of places, singleton gets used, but it means one developer created a singleton and everyone's using it.
Right.
And I've seen code bases where there are hundreds of singletons. Like, literally every class is a singleton.
Yeah.
They're all highly coupled too, which is like, well, that probably fits the point.
So I think I want to take a second right now just for the listeners who may not even be familiar with patterns. I think eventually throughout the show we will kind of touch on and more or less define them, right? So I know we're just kind of diving in, and we've all been in the industry for a while, so we're just kind of throwing them out, and we know what we're talking about. But I think we will eventually define all of these things, right? I don't want to sit here and be Wikipedia right up front.
Yeah. But I actually have a pretty good definition of what a design pattern is.
Yeah.
It's one I've worked on for a number of years. Because you really, and maybe Wikipedia has something, but years ago when I did a bunch of research around there was no good, like, this is what it is.
Yeah.
And this is sort of what I came up with. A design pattern is a known, proven solution to a specific problem within a context.
Mm-hmm.
And that last part is very key. A lot of developers will use patterns and things, but they don't necessarily understand the context. I'll use a perfect example. You wouldn't use the repository pattern for a UI.
Right.
Or you wouldn't use the model view controller pattern to do data access.
Right.
So, or like Chris talking about the strategy, you wouldn't use strategy to create new objects. There are certain elements and things that matter, and really the context should drive things. Because again, it's more important that you understand, I want to solve this problem in a certain context, more than necessarily you can list the patterns of the Gang of Four book.
Yeah.
Right. But I think what's interesting is that you could also use them to avoid reinventing the wheel. And what I mean by that is, I think when you're getting started, maybe especially in a language like a C# or a Java, what are the constructs the language gives us? Ifs and whiles and for loops, and you just force a way to get that process described to the computer, no matter how nasty it is. And then all of us go through the evolution, I think, of, man, this code's really hard to work on, and you begin to discover, whether for yourself or because you have a good mentor, ways to make the code easier to work on. And what's refreshing when you finally look at the patterns defined, maybe if we say the patterns that defined using the names that we've given them just a few minutes ago, is you might say, I've done something similar to that, but it wasn't as refined. Or I see now how, like, if I just took that idea that I had that I thought was, oh, this is a cool way for me to write my code. Well, this takes it all the way to the end where now it's easy to maintain.
Yeah. So I had seen it described somewhere, it being patterns. I'd seen patterns described somewhere as basically a common vocabulary for the team.
Oh, definitely.
No, I mean, and so conceptually, theoretically, that is what it is that, when I say singleton, you say singleton, it's just kind of a shorthand of describing something that we all know. But that's not what I see in practice, because we kicked off the show joking about the manager. The manager, right? And it's because the term manager, just means absolutely nothing. Now, manager is not a pattern that anyone has ever described or defined, but I have seen people use a repository and call a class a repository when in fact it's a proxy, right? And so it just, at that point, it defeats the whole purpose, right? And so I agree that is kind of the goal, is for it to be a common vocabulary. But how do you guys have any kind of tips on how you get your teams kind of speaking that same vocabulary and define those things up front, rather than everyone on the team kind of defining, what I think of a proxy is what you think of as a repository and all this other stuff.
You get to the infamous debate: what are services?
Service.
What is a service?
I love my services.
Everybody loves services. So I think it's a little hard to fully explain without being being arrogant about it.
Yeah.
You almost need to have somebody who really champions patterns, and they really need to be in the tech lead role.
Yeah.
Right? They need to evangelize patterns by almost forcing them on a team to a degree.
So are you saying they're the ones who are defining the patterns, and they're defining them for the team?
Yes.
So one person?
And over time, most of the people I've run into that sort of fit in that mold, they do reference the known names of Martin Fowler, Uncle Bob, and some of the other guys out there.
Sure.
So they try to evangelize the known patterns as opposed to making their own. I've been places. I've even made one of my own called the user context. I'll never see anybody use it, call it anything else, but it's a pattern I've used for years that it just makes sense.
Can you, real quick, can you just kind of define what you were talking about just there? So you mentioned a couple, Gang of Four, Uncle Bob.
Yeah. So.
And we'll have links in the show notes,
yes,
of course.
Definitely. So.
What are your favorite resources for patterns?
So I think one of the other big challenges for patterns is it's not something you can really just Google or read up on Stack Overflow.
Yeah.
It's good if you don't remember off the top of your head, I want to implement this pattern. I know I want to do it, but I don't remember all the details. Yeah, you can do that, but it's very hard to learn them just looking them up, at least in my experience.
Yeah.
You really need to have two things. To me, you need a mentor, or like I said, that team lead who's like, we're going to use the strategy pattern, or we're going to use X, Y, and Z pattern. You need almost that mentor who's working on a day-to-day kind of thing, evangelizing it. And then the other thing is you really need to read a whole set of books out there. There's almost like 8 to 10 different books to really grasp all this stuff and have a full understanding. That's just my experience. That's my opinion. This is not something, like I said, you can just go to Stack Overflow or you can go to Wikipedia and read. You really need to sit down, read these books, and then apply them. And it will probably take you years even before you can grasp them.
Yeah.
Well, that was my experience, right? So I read like the Gang of Four book, but actually my favorite book was the Head First series.
Head First Design Pattern.
A
lot of people go to that one.
Yes. Well, because Gang of Four is almost like stereo instruction.
It's like a textbook.
Yeah, it's a college book. Yeah.
Yeah. But I noticed that after I read that, the next 6 months, my projects were all incredibly over-architected, over-engineered.
Because you go searching to use this stuff that you think is really cool.
Yeah. Did you guys experience that too?
Yeah, absolutely.
Is that common, do you think?
Yes, I've definitely.
I've other people say it too. Yeah.
I've went through approaches where I found a hammer. I know when I first did a lot of stuff, I
Yeah.
loved the template method. It's
You just
like,
go around
I'll just
smacking
go create a
everything
base
with it.
class and override the template method. It
Uh-huh.
really makes sense.
Uh-huh.
Strategy is probably the one I use now more than any of them.
Yeah.
Or the one I always look at is, do I want strategy? And there's a very good book, extremely good book. I can never remember the author's name, but the book's called Refactoring the Patterns.
Mm-hmm.
Where
Isn't that Martin Fowler?
It's a Martin Fowler series book, but it's written
Yeah.
by a James somebody.
Mhm.
Again, we'll have it in the show notes.
Mhm.
That must came out like 2004 or 5, maybe a little before then. And he actually goes in and shows you very real-world problems.
Yeah.
I think that's another big problem. When you read all these books, they tend to be very, we'll call them abstract, theoretical stuff.
Mhm.
There's not a whole lot of, how do I use this in the day-to-day things?
Mhm.
This book came out later, and it really gets into, they're like, okay, here's a switch statement. If you have 2, use if.
Yep.
If you have 4, use switch. You have
Yep.
10, now you need strategy. Oh, by the way, if you have 40, strategy's not going to help you. You got a whole other set of problems
Yeah.
to deal with. And it really gets into like maybe about 60 or 70 different anecdotes of here's when to what they call moving towards a pattern and moving away from a pattern. Because there's lots of patterns, and if you're not familiar with these, some of these names are going to come off sounding weird. There's a decorator pattern. I don't think I've ever used a decorator pattern.
Right.
Simply because I can't explain how to use it. And at the end of the day, it's a wrapper. And that's probably another thing too. I think it really confuses a lot of developers. A lot of these patterns are all trying to solve the same problem in slightly different ways. Like a facade and decorator are ultimately trying to do the same thing. It's another layer of abstraction. You want to hide the details of something, and you want to deal with this abstraction.
Yep.
But the way you implement them are slightly different. Well, the reasons why you would use them are slightly different too. It's funny, a long time ago when .NET first came out and we had SOA and some of the other things, a lot of people were using facade patterns. So like, I'm just going to wrap up my WCS services or whatever with the facade pattern. That kind of approach. We moved over to REST and stuff. I very rarely hear people refer to it as a facade anymore.
Yeah.
Um,
Well, that's the other thing is that you're already using a lot of these patterns and you might not even realize it. So one of the answers I get to that interview question a lot is the provider pattern from ASP.NET developers, right? Using the membership provider and the roles provider and everything. That's a legitimate answer, right? It's a legitimate pattern. It's one that I tend to hate, but
yeah. The funny thing is that's actually not the pattern, at least according to the Martin Fowler book.
Yeah, well, yeah.
The plugin factory pattern.
Yeah.
But no, again, I always equate it to most decent developers, at least on the Microsoft stack. If they can explain to you the details of why they would use a provider, that's pretty good, right?
Mhm.
They can then learn the terminology.
Yeah.
And I think that's part of the challenge of evangelizing patterns and things is I think most developers want to use them, but they're either not sure where to start, or they're concerned about overusing them, or they feel like they're just going to get in my way. Like,
really?
I
feel like most developers just want to write the code and get it done, and they do it in a very procedural way. And I don't mean that critically. I mean, it's like that's your thought process, right? Like, you think A, B, C, D, and so it's easiest just to write the code A, B, C, D, and it takes a whole lot
First
more
I should
thought.
do this, then I should do this.
I'm going to write the code like that, right?
And if this happens, then I should react this way.
Right.
And I agree, that's natural. That's the human nature of it.
Maybe I'll break it into a couple of methods or something.
Yeah.
I even think that's why the languages evolved the way they were. It was just natural.
Yeah.
The thing is, that is not wrong. The problem is developers don't take the next step. I've always told people design patterns are just you kind of look at it as it's almost like it's like a pyramid. At one end are design patterns. At another end, you sort of have what we call the solid design principles, which we'll have to define in a minute. And then sort of on the other end, you have this concept of refactoring or test-driven development. You kind of need to do them all together. These things they're not individual pieces. They're like Legos or they're a puzzle. They all kind of go together in order to be able to be successful with these things. And the whole idea of refactoring, which is the idea that I'm taking existing code and I'm going to change the structure of the code without changing the behavior. So, for example, if I'm reading code and I calculate sales tax for states, all right, I might today have an if-else condition or a case condition, but now I want to refactor it to use strategy or some other kind of pattern. The idea of refactoring is I'm taking existing code that works, but now I'm restructuring it to increase either the readability of it, the maintainability of it, sometimes even performance or extend it. That whole refactoring mantra almost needs to be ingrained in developers. And the developers I've seen who get that and feel like they can actually be successful with that, using patterns becomes much easier to them.
Okay, so I'm going to throw this out here right now
Yeah.
because it is the main argument against it. You're over-architecting. I'm just going to say it. I'm not saying I necessarily agree with that. I'm just, you're
So-
over-architecting. How do you respond to that?
So the first question you should ask yourself is, well, you're under-architecting. It's funny. I haven't had anybody tell me that in a very long time. So what you need to tell them is very, very honestly, like, okay, if you have, remember I told you the whole idea in the specific context, you need to say, okay, let's look at the problem. If I have 4 things to say, if this, else, if this, else, if this, else, and now I want to add a 5th one, it's over-architected in the incorrect way, right? By introducing that pattern, I'm simplifying that existing code. Now, yes, you're creating separate classes, which some people may or may not construe as being over-architecting. You get down almost to an opinion debate. Sure. And I think that people who do not get the solid design principles or refactoring are generally people who want to make that argument. And I would simply say, let's try it out. Let's change this code, this one little block of code, and look at it.
Yeah, sure. But it makes your code base bigger, right? More classes.
More classes, but I would like to think that your methods, class sizes are getting smaller.
Yes. Your biggest argument is the readability of code and the ability to add new things without breaking existing code. So in that example there, if I want to add additional states, if I have the if-else block or even the switch statement, every time I want to change something, I have to keep changing the existing code. Yeah. If I use strategy, for example, I can plug in more and more states without changing existing code.
I think to also continue to play devil's advocate, here's something that I've heard in a code base. I'm not going to defend the code base too much, but I think it's reasonable for someone to say, well, now, Todd, I have to jump around everywhere to find out what happens. I honestly, you laughed, so obviously you've heard that criticism, right?
Yes. No, I've been in a situation where I've done that criticizing too. You have to jump around. I think the biggest area I've ever heard of that is with interfaces.
Yeah. Oh, wow. That reminds me of a conversation that happened someplace where a developer in a dev meeting, began a passionate defense that we really should not be using interfaces in our code. I mean, it just makes the code so complicated and hard to follow. And I thought, oh my God, that we're going to just new up concrete implementations and then what? Change the code everywhere?
So I agree with both sides of that, right? So I totally agree. I use interfaces all the time. I love interfaces, but it is frustrating when you get to this class, this component depends on an interface, and I don't know at runtime what instance I'm getting. I can't be sure, and that's the power of it. Yeah. But that's also the downside, right? The power is that I can choose at runtime what implementation do I want to put in there, and I can even wrap them. That's where I use the decorator pattern, right? Where I take an object and decorate behavior, wrap some behavior around it, and wrap some more behavior around it. My favorite implementation there's actually a combination of interfaces and the decorator pattern is where you take something like, let's say a repository. Let's just speak even more simply, just a data access class, right? So something that has create, read, update, delete, the CRUD operations. And that's all it does. And every single time you call read, it goes to the database. It has no logic of, did I already read this one? Is it cached? Blah, 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 blah. And then you wrap that, you decorate it with caching logic. Right. And so you have the core class, which all it does is the CRUD operations, and it does them every time, and it's not intelligent at all in terms of optimization. And then you wrap it with that caching logic that optimizes like, hey, I already saw this read for this ID, so I'm just going to return that cached one. And if I don't have it, I'll call the base one that will call the database.
Right.
That is perhaps my favorite use of patterns, that specific kind of thing. And what makes that possible is interfaces and that decorator pattern. Yeah, and the abstraction.
But
But
I think I still
at the
want my.
cost of, I don't know what at runtime is going to happen, right?
But
So-
I think I want my front end to not know, right? I don't care what you
That's
did
the
to
whole
get me the
point.
data.
Right.
Because-
you're depending on the interface.
Because what I would like you to be able to do, and I admit that this is extra work, is I'd like you to be able to supply me with an implementation that just runs in memory or off a file or something,
Yeah.
so that I can go work on an airplane and not need to be wired up to the data center.
Yeah, except when something goes wrong with the implementation, and then it's crucial that you know what implementation you have so that you can debug it, right?
So here's how I've dealt with this problem in the past, because I actually have come across quite a few developers, and in my opinion, I'm going to be a little frank here. Most developers who say that do not get patterns. They
Yeah,
are
sure.
afraid to use them. They don't want to get them. They're lazy.
Who say
Here's
what?
how that it's over architecting.
Yeah, okay.
Almost 95% of the people that I've run into who made that statement are people who do not get patterns. So
I guess. I don't know. I've definitely over-architected systems.
well, no, you can.
Oh, yeah, sure.
You can definitely over-architect with patterns. That's the reality. But that's where refactoring comes in. I think what we're getting at here is there is another level, another starting point, and it comes back to very simplistically good OOP, right? It's about abstraction, right? When you come to a problem, the first question you have to ask yourself is what level of abstraction do I need? And you made a perfect good argument, right? You said an example of I'm just going to have my data access get the data, and I'm going to use Decorator to wrap them to do the caching.
Yeah.
That makes perfect sense because you're separating the responsibility, right? Data access is doing a data access, and if I need caching, I'm going to use this Decorator. And if I do not need that caching, I'm just going to bypass it. That makes perfect sense.
Or you could implement new caching rules and wrap those, right?
Yeah, whatever.
Or
makes-
vice versa. You could
I don't have
switch
to
out
care
the
about it.
actual implementation, but keep the same caching rules.
Yes,
Right.
exactly.
Yep.
And I think you almost need to, I hate to use this word, trick them, but you need to educate them in a way that makes sense to them. So some developers they just don't want to embrace it, right? They're either come from the camp of they want to drag and drop everything, or they are afraid it's going to or they're afraid to over-architect problems.
Well,
So
so you
you-
have to sell them on the value, right?
Yes.
So what is the value? What is
So-
the value proposition of these?
Yeah, I think again, my point was, if you get abstraction, right? You start at the simplest problem, abstraction, maintainability of code, and then you start learning about patterns. You will discover that patterns solve a lot of these problems because they're proven, right? Other people are using things. You're not reinventing the wheel. But you really need to get back to that quintessential thing, right? You need to think of abstraction. You need to think of, I want to make my code readable. I want to keep my code small and compact. A lot of developers get the idea, hey, I want the least amount of code, right? That is I'm going to say it's a CS flaw. Like in CSS or CS, in CS classes, they teach them, you want the least amount of code. That's not always true. You do want the least amount of code, but you need to do it within the context of the problem you're trying to solve. So anyway, I'm getting kind of off track, but back to my original point here is developers need to have to learn how to collaborate together and communicate together, and patterns help that communication level, right? You were talking about before. You mentioned Decorator. I know what that is, so I know what you're describing. I don't even need to look at your code, which is a good thing, right? The other thing is, I think, and this is, I don't remember exactly when it got put into terms, but I almost think it's more important to learn Solid nowadays, the Solid design principles, than it is to learn design patterns. Because if you think in Solid terms, the Solid being the single responsibility, open close, et cetera, et cetera, et cetera, we're not going to go into a big explanation on the show because it's too hard to explain with code examples, let alone abstract. Those principles guide you a lot of the ways towards certain patterns, right?
I agree completely.
Huh?
I agree completely. I spent plenty of time researching, reading books, reading the Gang of Four book, reading the Head First Design patterns, using the Decorator pattern, using the strategy pattern, blah, 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 blah. All of that before I found the Solid principles. And now, I'm not going to say that all of the other patterns are useless, but the Solid principles, in particular, dependency injection, single responsibility, they're the driving force behind everything that I do. And I'm not going to say they're all that I need, but if that's all that you use, I think you're going to end up with probably a pretty good system.
And the funny thing is, they all drive you towards a pattern, right? Dependency injections, the version control pattern. Now you're like, well, in order to make this work, I need interfaces.
Exactly.
I need
They're
to
all
figure out
complementary.
abstractions.
Mhm.
They're all
Yep.
kind of built upon each other.
Yep.
So before we started talking, I kind of put some notes down, and I thought of, and we kind of hit on this. There's almost we've in the Microsoft world we used to use these terms. There's Mort, Elvis, and Einstein, right? Mort being the VB developer, Elvis was the C# developer, and then Einstein was the super C++ developer. So thinking in that same kind of terms and personas, I really think when it comes to design patterns, there are three groups of people, developers, trying to fall into three groups. There is, I've never used a design pattern, may never have heard of them. And there's lots of developers who write great systems that do that. Then there's the people I've heard of them, maybe read a book, but all I ever really know is Factory or Singleton, or I use ASP.NET MVC, which is not a pattern, it's a framework that happens to implement a set of patterns. And then there's sort of like, well, I'm going to call, and I consider myself part of this group, the hardcore patterns bastards who are like, we will easily do everything. And they're like, well, Martin Fowler says this, and Uncle Bob says this. And I guarantee you, in a room full of developers, maybe you get 25% who even know what the hell you're talking about.
Yeah.
They
think you can probably break the whole system down into a series of patterns from these texts, right?
Yes.
The entire system. That's the hardcore group.
So I think that, and it's funny, when I was doing the research for the show, I thought about where does someone start, right, to learn things? Like, how do you get grasp things? You start just reading the Gang of Four books, it may not make a lot of sense to you, right? Particularly because that's written in Smalltalk. There's a whole set of other books out there. And I think we almost need to get back to, or I would tell any new developer who really wants to grasp patterns, is obviously start with Solid, right? Understand it, do research, figure out what people are doing with those principles, and then just try to start using them on your day-to-day job. Create a class and say, you know what? I'm only going to give this one responsibility. The minute I have to do something else, I'm going to give it something else. And then get back to good fundamental OOP. Go back and read some of the early books on just object-oriented programming. Like, why was that invented? What problem was that trying to solve? And figure out where that fits into your code.
Is it even still relevant anymore?
I argue it's even more relevant.
I argue it's less.
Well, that's a whole other show. To me, why object-oriented programming is more relevant is because if you think again with Solid, they kind of work together, right? If you sit down and you can describe your code base in terms that are not code, like, okay, I'm going to have a customer, and a customer is going to do X, and I'm going to have orders, and orders do this. If you could describe that, to me, it means you have a better, well-designed code base because you're modeling something in the real world. Any developer, that's an easy concept people can get, right? If you and I describe customer, we're an e-commerce system. We can all communicate without ever looking at the code. The code should be implementation details. It shouldn't be like the system. The system should be able to describe it in terms that aren't code-based.
Yes, but so the reason that I argue that object-oriented programming is less relevant, and because objects themselves are less relevant, because the definition of objects in object-oriented programming is data and behaviors, right? And so, but that doesn't really model. You just said, and you might have misspoke, so I might be picking on it a little bit too much, but you just said the orders do something. Orders don't do anything. Maybe customers do something, maybe, but really you don't want to have a customer object or even a user object, and that class, that object has every possible thing that that customer can do. That's insane, right? That's gigantic. So what you do is you break these things down into context, into workflows, and it's the workflow that has all the logic. And then the customer and the order and all of these other things that used to be objects, they are now just data. They contain data, and they're just data that kind of gets shipped along the line and gets operated upon, as opposed to performing operations themselves.
Well, they're just like records.
Exactly.
We use objects because that's what we have in C#.
Right.
Okay.
So that's how I tend to write my system, right? I have these data.
Remember, we got scolded for an anemic data model, right?
This is the idea that it's very important to read the entire Martin Fowler book.
Sure.
What you just described is the fundamental flaw of software development. It is not data. It is state, right? Objects have different state within different contexts. You're right. Different workflows drive that, right? And those are classes. Those are object-oriented classes. They have responsibilities. So if you're going back and forth, when I was actually talking more about abstract, right? Because
Sure.
we use
Yeah.
UML as an example.
'Cause-
You have a logical model, and then you have a physical model. So in the logical model, you would say order has this set of responsibilities. As you code it, you would potentially create just different workflows. It all depends on what the problem you're trying to solve. If I'm trying to calculate all the orders for a region, well, the region class probably should have that set of behaviors, because that's the context. And there's a whole set of things which you cannot unfortunately get into in a talk or a podcast called domain-driven design, which specifically address those things. It's specifically called out as you have services or workflows that do X, Y, and Z. The problem I've seen is too many developers still think like databases. Because that's usually what a lot of developers learn first. They think of, I have a SQL table that's a customer, I have one that's orders,
it's where you store stuff.
Relationship, and then they try to build objects to follow that same path.
We've even built object relational mappers.
Well, that's actually a solution to the other problem.
Right.
I've found, at least personally, I've found it to be much more successful, and the people that I've seen that can really grasp this stuff and be most successful with it, they don't even think about the database. Right. It's just somewhere to store it, the state. What they think about is these classes and objects and the behaviors. Right? We even have a term, behavior-driven development. The concept of what that all is this idea that I want to define the behaviors of my system.
Yeah, well, the system has behaviors.
Yes, the system has
logic. Objects don't have behaviors. So let me rephrase that. Behavior-driven development does not mean that objects have behaviors. It's describing the system's behaviors.
Yes.
Whether those are attributed to objects or not, that's TBD.
Yeah. And then, which again, if using Solid is a good practice, what you were describing was Solid. The idea that, well, maybe the customer shouldn't have a way to calculate all its orders. Maybe you need a aggregate object, a customer order object, or a customer history object, or like order history object that does those kind of things. And those are things that, in the domain-driven design world, you define as the problem domain gets defined. You start out with customer and order. Then you simply say, what is the problem? Well, the problem is how many orders does the user have this year? So you figure out, where does that responsibility belong? And when you apply Solid, you'd say, well, it doesn't belong in customer, because customer is a single responsibility. It's just representing the state of the customer, right? Their name, their address, whatever. Order, is this a point in time of something that's being shipped? So now you need something else, that workflow class or whatever you talked about.
So when we talk about patterns, we're talking about design patterns at first. And I know there's more than one type of pattern, but if we try to define what the design patterns book, the famous book that everyone, you just go Google Gang of Four, and you're going to get the book we're talking about, right?
Yes.
That's how well known that book is. It's considered a classic. I'm going to just throw out somewhat of a hypothesis. Believe me, I didn't make this up. You can find it in the foreword, right? Is the purpose of those design patterns was kind of to get us to stop using inheritance to solve problems. I mean, that was a huge goal.
Yep.
Because, and I think, and isn't that interesting, right? Because if I take a journey back in time to when I was a CS student, what I remember is okay, object-oriented programming, I don't want to say it was new, but it was becoming commercially popular at about that time. So, okay, everybody, the pillars of object-oriented programming: encapsulation, polymorphism, inheritance. And inheritance has failed us. Right? I mean, I don't think I'm alone in believing that. And so, instead of, Jess, you were talking about the decorator pattern, where instead of saying, in fact, if we use the head first design patterns book, they have like a beverage, and they start inheriting off of beverage to make like a mocha and a hot mocha and an iced mocha, and it's crazy. Now you have too much code to maintain. So the idea is to layer on the aspects of the beverage. This is an iced beverage, and if I wrap that around a mocha, now I've got an iced mocha.
Right. Well, and these are object-oriented design patterns.
It is object-oriented, but don't use inheritance.
Well, yeah, right. But also many of them do kind of apply even when you go into more of a functional mindset, right? So you can take it might not necessarily be called the same thing, and it might be somewhat different, but like wrapping a function with different behaviors, meaning, maybe modify the inputs coming in and modify the outputs coming out, that kind of stuff. The similar concepts
Well,
Wow.
the difference in
Maybe that's
functional
crazy.
programming, the key difference is state is not a concept. You
Right.
never have state in pure functional programming. Now,
Right. Yeah, but
you've
it
got to
puts
have a
an
side
output.
effect at some point. You've got to write to disk. You've got to write to database, and different languages handle that differently. But when if we're going to talk about the design patterns book, this was definitely aimed at object-oriented programming. So there is an assumption that there's some state, and the reason why. So we talked a little bit about decorator, right? And we talked about strategy being popular. And I can tell you one reason. What's a canonical example for strategy? The sales tax calculator, right?
Yeah, or
I'm just going to make
fruits or
that up.
vegetables, whatever
Pretty
shapes.
good one.
Yeah.
That way I can give you the California sales tax strategy and the Nevada sales tax strategy, and then you just
Or
plug
call
it in
a
as needed.
sales tax service.
Sure.
Right.
So that's
Today,
interesting. Does that flip strategy around and say, I don't really even care how to calculate sales tax. Jess, your service does it.
Yep.
It all depends on the details. So
Now,
if you're
are
thinking
those
about
design patterns? So I guess what I want to do is I do want to say those are object. Am I wrong if I say we're going to define those as object-oriented design patterns? But I want to make sure I stress for the people listening, that's not the only kind of design pattern. I mean, there's a Martin Fowler's famous book, Enterprise Design Patterns, is more about the design of the system,
yes,
right? And maybe that goes to what you just said, Jess. Is in your case, you're now talking about the design of the system. Is listen, Chris, don't even worry about sales tax. Call my sales tax service.
Yeah, sure. And then you get into eventing and those kind of patterns as well.
So talk to follow on your point real quick, Chris. The answer to your question is yes. There are different kinds of design patterns. What Jess and I were debating about, those are different design patterns. I was equating to the idea that if you really want to get design patterns, you need to grasp OOP first.
Yeah.
Understanding OOP concepts will make you a better developer. Understanding the idea that there is state, and I want to care about the state and then behavior more than how we're going to persist it.
So let's get some good concrete advice for people. When do you use inheritance in your own code? No, I'm not talking about framework code. Just the fact that let's say I'm going to use ASP.NET MVC. Okay, well, I'm inherited today. We're not talking about the new version, but today I'm going to inherit off controller. So I've already bought in. When are you going to use it? Do you? Do you avoid it now?
When I do avoid it as much as possible. When I do use it, I really try to strictly keep to one level of inheritance. So in other words, I will have a base class and I will inherit from that. And I'll use it for the kind of traditional reason of I have some code that is literally the same exact code that I want to share amongst different derivatives of that, right? So based on the different types, that logic still applies to them.
I don't want to get too deep into it.
For me, it's what you just described, Chris. For certain frameworks, you do need to get yourself in the door. You got to inherit from something, right?
Sure.
But you should try to best you can to avoid multiple layers, like Jess was talking about. In the terms of controller, sometimes I do create a base controller, and then I'll have my controller inherit from base controller. But I would never go past that, and that's usually for a set of specific things like security. Or again, because of the way the model works, the workflow works for ASP.NET, I almost sort of have to make that work. For everything else,
oh, go ahead.
For everything else, I use the concept of root. There's a root thing into my system. All right, that I try to avoid inheritance of the root, but I may have children of that may have inheritance. I'll give you a perfect example. We talked about the caching or sales tax or whatever way we want to have different kind of implementation, the strategy implementation. I'd have a root class. We'll just call it service for now, to keep terminology terms simple. If I had a certain kind of behavior that says when we use logging as an example, when I want to log to disk or I want to log to databases or I want to log to a third-party system, I'd almost design around. I'd have a root log object that I work with that would then have certain strategies that would dictate, all right, now this is written to disk, this is written to database, this is written to this third-party system. Because what I've done is I've isolated the inheritance. I've worked on a lot of systems where we had 3 levels of inheritance. So we had the top level inheritance, we had the configuration level of inheritance, and we had sort of a third thing that had inheritance. And every time you added a new type, you had to go touch all 3 trees.
Yeah, sure.
And all of a sudden it became overly complex. that could have been greatly simplified if we had a more of a root concept. We had the thing object, and the thing had a set of things related to it through composition as opposed to inheritance. So you're right. A lot of these design patterns were around promoting the idea of abstraction and isolating the need for inheritance. I always tell people there was a reason in C# they made single inheritance. It's because it's never the right answer, other than very small set of things, like getting into the framework, right? I have to inherit. I can't create a controller without inheriting from controller.
It's funny. I actually have a thought about the loss of multiple inheritance with Java, which I think C# just inherited, but maybe it's for another time. So we started off the show talking about how everyone says singleton. Now, I think I can presume that you guys don't like singleton.
No.
Oh, I hate singleton.
There's a rule. Never, ever use singleton.
Well, now let me
absolutely have to. Never use static.
Let me say this. So let me ask you this. I'm not saying you should have tons of singletons in your app, but now let's go ahead and let's go take a look at ASP.NET again, right? There is a global host singleton that kind of provides you like maybe some information about the web server, and I think maybe the reason why is because I don't want to go new that up, right? I'm living in a web server. So let me rephrase. Container that I'm living in is never going to change.
Right. So let me rephrase. So
at runtime.
Exactly. So there is when in your environment there's only ever one thing, then the singleton pattern as a concept represents the world you're living in, right? It reflects things properly. To be very specific, the quote pattern that I hate is a static singleton. So on a class you have a static property or whatever, and that is what you get to. So the implementation in ASP.NET, HTTP context.current. That is a very specific thing that is hard to abstract around, right? And so to the point where recent releases of ASP.NET have actually gone to the HTTP context base, right? And so they've
made an abstraction.
Exactly, and so that's what all the methods take in as arguments and everything, and nobody ever really goes into it depends directly on HTTP context.
So is this a case where go ahead.
So at a certain point, though, the concept of singleton does apply. When you do have this one thing that will only ever be one instance, this makes a whole lot more sense when you're in the UI, like a native UI, or even in the browser. You only ever have one browser window, right? You only have one desktop, one PC that you're running on when you're in a native app. And so to have that represented as an object is great. It reflects reality, but you shouldn't go to one specific place to get that, right? So when I implement the pattern, I really prefer to do it in something like a dependency injection or an IOC container where I still kind of get injected that instance. I'm still looking at an instance. And the fact that I always get one single instance all the time, the same instance all the time, is irrelevant to me. I operate on the one that I'm given, and at runtime it just always happens to be the same one, right? So you're still using the singleton pattern, but your code is not coding against that pattern. I don't know if you guys disagree that that's even
No, I mean that again, getting back to solid, that is the whole meaning of D in the solid principles, the idea of the version control or dependency of version. Yeah, and to me that is actually, there are cases I use singletons. It's funny you brought up JavaScript. I use singletons a lot in JavaScript because sometimes the language is just weird to work with. It's just easier to work that way. But in like .NET and stuff, you really should be using a DI container because for a couple of reasons. One, you're now abstracting away if it's a singleton or not. That's in configuration, which means you can change it. It also means you're not marrying yourself to this being a singleton. When a lot of people use singletons, what they end up doing is they proliferate all over the place. They're like, all right, I created a singleton for this, so now I'm going to create a singleton for this. Now I'm going to create and all of a sudden you have 10. And because it's easy to work with, it's very easy to go HP context.current request. So even before the days we had MVC, one of the very first things I did, and this is how I invented the user context concept, I abstracted all that away. I'd have a base page in web forms. I'd abstract away HP current because I didn't want all my developers. I want every line of code to be HP current.request. I wanted people to use an abstract concept of request as opposed to the raw concept of request. Just because it would proliferate that same code all over the place. All of a sudden, the class they're passing HTTP context, and that we never wanted that class to have that direct reference.
So is there we were talking about, I mean, I tried to bring up the concept of inheritance to say, we're not using it in our own code, but we might have to use it to buy into a framework. So is it the same thing with singleton? You don't want to see it as something you own, but if you have to buy into it because of a higher level framework like ASP.NET, that's okay?
Well, you sort of, before
Maybe
we
not a hard and
abstract
fast
away, you
rule,
were
but-
kind of stuck with it.
No, see, we're stuck with it, but we agreed that there are circumstances where it's useful, but is there a reasonable rule that it just probably shouldn't be in your app code? As framework lower level code, maybe, but in app code, what are you doing? Like, no, I'm not hard and fast, but maybe 95% of the time it smells awfully bad.
So what I tell people is never use it until you absolutely convince yourself you need to. It's almost like the evidence. Start with just newing it up every time, or using a dependency injection framework. All of a sudden, if you feel like, well, I need this all the time, I need that same state. It gets back to state. I need that same thing in that same state. All right, now you need singleton. Prove it to yourself you need that. Don't just create a singleton day one because, oh, it's just convenient to get to it.
So another popular one, sometimes we see it in frameworks. Do you guys write factories in your app code? This is something you're gonna, yeah, we'll use factories. And the purpose of factory, I'm gonna sort of take a stab that the purpose of factory is to prevent you from using new, the new keyword.
Isolating new, where new is going, yeah.
Isolating it into like a set of criteria maybe that you provide the factory.
Sometimes. I more depend on dependency injection containers to kind of choose the right implementation rather than create one on the fly. Although I will, in pretty much any dependency injection container will provide you the ability to say, for this type, use this factory, that is the factory pattern, and I do use that every once in a while, but it's generally few and far between for me.
So which if we have a list of them, things like, I don't know, the command pattern, we talked about like adapters and facades. Do you adapt to kind of bridge two classes together? Although I just named another one, but
yeah, I've done it. Again, it really depends on what I need to do.
So what do you think developers need to know? Like, what should they study in terms of these OOP patterns before maybe we think about other types of patterns?
I think that you learn solid and you learn dependency injection.
Okay.
If you were going to start today and you had no knowledge of any of this stuff, solid and dependency injection is where to start. Once you've done that, then I'd recommend you go back to the older books on good OOP programming, because they just give you some of the fundamentals of why you want to create classes that do X and call them a certain names and things. But if you start doing that, if you start using dependency injection within reason, you can't necessarily want to use it for everything, you will start like all of a sudden doing these stuff just because you want to use dependency injection.
Yeah, it lays a good
foundation. I need an interface. I need to do this. I need an interface.
Yeah.
So now I want all my dependencies to be injected in. Okay, I want it. That's sort of like it's sort of the carrot.
Yeah.
In order to do, or even do like TDD, in order to do TDD, you kind of get forced to start thinking this way.
So
and then
that's where I was really driven toward Solid, is to learn how to do TDD correctly. So I came the other way. I didn't learn how to do Solid and then did TDD. It was the other way around, that I was really learning how to do test-driven development and learning really what a unit test was and what a testable thing was. And the first project that I did it on, I just completely screwed it up.
Right,
and I realized it was because my system wasn't testable, because I couldn't replace components and I couldn't test components in isolation. And effectively, the only real way to do that is with the Solid principles, specifically with dependency injection. And so I went and I learned about Solid. And that is just the way that I developed. Far and beyond any of these other, quote-unquote patterns, the Gang of Four patterns, all the other patterns, like, it is Solid that drives my day-to-day development.
And
I'll agree with you that for me it's testing. Testing was my big motivator, because I think we talked a little bit about why should you learn patterns. And because you can come around to a pattern, you can come around to either using the Solid principles or using one of these design patterns when you get to that testing point. Because if you just write the code, you just write some imperative code, you write out a process, and then I'm going to cheat a little bit and say like, and then your manager comes along and says, let's get the code coverage going, Chris. So you go to write the tests, and they're awful. They're awful for two reasons. One is that you've got so much imperative code in your 400-line method that defines a process that testing it, even writing the tests, is extremely difficult. Or you have to write dozens or perhaps 100 tests to test the entirety of that monstrosity you've created. Then second, when a business rule change comes along and you go change the monstrosity, you break dozens of tests. And so now you start to hate it. Like, I can't believe I'm doing this. So the purpose of learning the patterns is so that you can try to write more isolated code that's solving one problem at a time, and you can use patterns to, patterns can lead you to solid, right? Solid's the principle, single responsibility principle. I want to follow this principle. Well, how can I do it? Well, I can use patterns to get there. And why do I want to do it? So now I can write tests that just isolate this little piece of work and here's where, for me, dependency injection, dependency injection is a fine thing, but I strive also to break dependencies.
Yes.
I don't want to just grab them because it seems like, well, because I've seen that. The kitchen sink, oh, hey, we're using a dependency injection framework. So, it gets very easy to just throw 7 things in the constructor because I might call one of those methods. And it's not that I might. I am going to call one of those methods. But now I start to say, now wait a second, that object that you're creating, maybe it's doing too much. If it's taking like a reader and a writer and a calculator, well, now it's doing too much.
Yep.
And
that's how they reinforce each other, right?
Right. And I want to break them up again. And to me, the clue, the trick, the smell, is when I go to implement the tests and I have to mock 4 things to get there, or the mocking code to set things up gets long.
Yep.
Hold on, I'm probably taking a dependency that I should break off into another responsibility.
Yeah, I think you're spot on, right? These things
and
are
I keep getting there through tests because what I don't want is the business to say, oh, we'll just have some people click through the application to test it. That's what I kind of think failure looks like.
Yeah. So it's funny. A lot of people, they often talk about the idea that it takes longer to do TDD or it takes longer to use patterns and things. This is why I said these things in the beginning, these are sort of all-encompassing. They're not one thing. They're pieces of a puzzle when you assemble them together. If you look at software development as a big end-to-end solution, right? We all have a beginning, and eventually you deploy something. The amount of time we spend...
Sometimes you deploy.
Most things to get deployed in some state. The amount of time we spend actually testing the software is very little, right? In a whole, right? And you then give it to a user, and they find problems, right? The problem is with all this approach is you don't know where it broke, right? You just described it. I have a method with 600 lines of code. Where does it break, right? It could be 100 different things that broke in there. But if you start thinking about things, I get back to abstraction. The abstraction, which is the one thing also in the original OOP things we thought of, and the actual design pattern behind dependency injection, the aversion of control. I want to separate dependencies to make things simple. I want this block of code to be as simple as it can be. Overall, the system may be more complex, but by doing that, it's more testable, it's more isolated, it's more replaceable, which then makes it more maintainable.
Yes.
You have confidence that this block of code that's going to go get data from the database, it works. It does exactly what you expected.
Yep. Well, you break things down to their smallest possible parts.
Like you described in the beginning, Jess, of caching. Caching has nothing to do with getting the data. Those are 2 separate things.
Yep.
And you may need caching other places in the system that are nothing to do with getting data. Those are different behaviors. So that's always, back to the beginning, I was like, if you could sit down and on a whiteboard or notepad or whatever, what are the behaviors of this application? What does it need to do for the user? If you start at that level of abstraction, then you start breaking it down and eventually you get the code and stuff. I think you will eventually discover that TDD, patterns, and Solid are the tools you'd use to figure out what code to need to write when you start with those behaviors.
Yeah, I agree. But back to what Chris was talking about, when you have these gigantic methods and it's just very difficult to use them, let alone test them. It's certainly difficult to test them. It's because in order to get to line 200, which is the one you want to test, you have to first get through lines 1 through 199. right? And they have all their own needs and dependencies and
Yes,
everything.
for a certain state they
You
might
need the whole universe set up again
Yes,
in
right.
order to
And
just
so
test your
if
application.
you just break out line 200 and maybe a couple lines above and below it into its own method, then you can start getting at it directly, and you can isolate its dependencies and break everything down to its smallest parts. And then you can then go and replace those 2 or 3 or 5 lines easily down the road if you need to, or fix them, tweak them, or whatever, and tweak them with confidence, because now you can access them directly.
So when we talk about what our languages guide us to, okay, I find it interesting that .NET just built in Observer. Now, do you think they did that just to facilitate GUI programming?
You talking about the whole event delegate? What do you mean by they built an observer?
I mean, to me, that's the observer pattern. I don't. Maybe I'm wrong, but I feel like it is. It's an event, and I subscribe to it. It's not using the same terminology as the Gang of Four book, but I mean, I'm subscribing to an event, and then I get notified when something happens. I could be one of several listeners, right? I feel like the observer pattern's built in, and I've always found that curious. That why did they make that choice in .NET, and was it just to simplify, interacting with WinForms and the ASP.NET Web Forms that we had back, when this stuff came out? And why could other patterns maybe be part of languages? I don't have an answer to that question.
Well, I mean, if you look at nowadays, right? What is a big one where a lot of us are using? We're using async await, right? That's a pattern.
Yeah.
I mean, that is a quintessential example of they've built a pattern into a language.
And
They use it very
observables.
hard to implement yourself and get working.
Okay.
So,
You mentioned at the
lot of
top of the show,
boilerplate there.
Chris, was observables, right? And so observables in .NET have been around for a while, and then there's RxJS, right, in JavaScript, which is, and I think observables are coming to the actual language, and just that is an implementation of the pattern, and it's just there for you.
Right, and I mean, I think I get what you're saying about like adding a language feature for async await because, after what they've taken 3 or 4 cracks at async patterns, right?
Mm-hmm. At least.
Why don't we just build it into the language? Because before, when there's iasync result and there's that begin end type pattern, what was that called? I forget already.
The callback type, that was kind of a callback pattern.
Yeah, but so now it's like, well, what if we just build it in?
The tactic sugar.
Yeah.
I mean,
So,
look
do you
at
want to
Link,
see
right?
more of that? Well, Link definitely.
I mean, that's just it's starting sort of problems, right? The whole querying of things and
It's heading towards a functional paradigm by saying
Yes.
let's map over collections with these operators, right? Because a lot of the stuff that you do in Link could be implemented just as map, but it's nice to have those other features too. So yeah, so there's all kinds of different patterns to help us from day to day. It wasn't just the OOP patterns. There's also getting to use Link or async await and stuff like that. I guess what I'm looking for is, what do we tell a junior developer about, somebody who's pretty new, they're learning languages, they're banging out code, and they may even be doing a great job of implementing the process that you need to get done, but then you go look at the check-in and you start thinking about the technical debt of maintaining it. What are we going to tell that person?
I would say is you sort of hit on it. The frameworks and stuff you're using, what patterns did they implement, and why did they implement them? Like if you're using jQuery, why did jQuery use the module pattern to solve a certain problem? Understanding the frameworks and what they're using, if you start thinking in their terms, like, okay, they've created the observer pattern. Like, why did they do that? What is it doing for me? Because I think a lot of developers do that. They use stuff all the time, but they don't necessarily understand what's happening on the covers. So it's important to think to start there and then read. You cannot be afraid to read and learn and go to ask other people. I mean, we have this great thing called the internet nowadays.
There's
Right.
a lot to read, almost too much.
Yes.
And some of it's not good.
Yes. But before, he mentioned the first time he used loads of stuff, he did it wrong. Don't be afraid to do it wrong. It's okay to write bad code if you're going to refactor it and understand I needs to change.
Yep.
I always tell people in the beginning, when I first started thinking, I always thought about I had to write code 3 times. First time is just get it working. Get whatever I'm trying to do working. The second was basically refactor, get it to whatever so it looked better. And the third time was optimize it.
Well, isn't Kent Beck make it work, make it right, make it fast? Is that him?
Yeah, there's kind of he has that same he's a better description I did.
Yeah. Well, my number one thing, as always, is just break it down into the smallest part, right? How do you eat an elephant one bite at a time, right? And every system is an elephant. Even if you got the smallest little application, that's what I've been accused of over-architecting plenty of times in the past. But
Sure.
Breaking a problem down into its smallest parts is just, generally speaking, it's a good thing. It's always going to help you. And so then the patterns in general help you do that, and they help you kind of reassemble those small parts back into usable chunks in different ways. And the biggest thing that you need to learn about the various patterns is, to Todd's point earlier, what is the context? When do you use them, right? But ultimately, it just comes down to, and I hate to, this just seems like totally dodging the question, but like, think about what you're writing, right? Don't just sit down and just say, I need to write this process out, I need to write this workflow out, so I'm just going to write 500 lines in one method and be done with it. Think about what are the components of that logic, of that workflow, and separate them out, and then kind of step back and think at a higher level of, what does this system look like, right?
How can I make it better?
How can I make it better, right? What parts of this thing might I want to switch out later, right?
Sure.
And if I have an if statement, an if with 6 ifs and a couple of else's in there, yeah, maybe that's a strategy, right? Each of those, even if right now those are one line a piece, that's some of those examples where you might get accused of over-architecting, but it might almost be a coincidence right now that they're only one line a piece, right? That doesn't mean that the next one that comes along isn't going to be 100 lines, right?
Or the next developer that comes along isn't going to put 17 lines in that next else.
Exactly.
Exactly. One thing I wanted to equate to, and Chris, you talked a little bit about when you're talking about TDD, is I think sort of a closing thought. Any code you write, and TDD is a good way to practice this, pretend you're also consuming that code. What do I need to call this function? Right? If I have to new up this class and it requires 6 dependencies, but in the code I'm calling it only needs one of those dependencies, that should be a light bulb going off in your brain going, maybe these two pieces aren't in the right, they're not correctly correlated together or being coded together. Like they're not in the right places. If you have to constantly keep writing to consume your code, which again, TDD, this is the idea of TDD, right? I'm writing the test to get better design. You will start to force yourself to start thinking about, well, maybe I need to separate some of this other stuff out, or why do I have these other dependencies in this class, right? Maybe I'm passing them around to other things, and then you can start thinking like, how do I break that? How do I simplify it? Again, I always tell people, if you're doing it right, you have lots of classes doing very small things. You'll feel like you have 10 too many classes in your project, but if you're doing that, you are generally going towards the right approach. And then you need to learn when you have too many classes and refactor back the other way.
Well, then you need to introduce things like naming patterns and things to be able to find things.
Yes.
Then you have a new problem, and that's finding things.
Yes, but again, if I can talk to a class and within a few lines of code, I can call the method and get the result back I want, then you're doing it pretty well. If I need to, like you were talking before, Chris, if I need to set up 100 things to just call a method that calculates something, then whatever I'm calling is overcomplicated.
Right.
It's doing too much.
Yeah. So, I mean, patterns, besides giving us a common language that, like, even the three of us were able to talk about a few patterns without really going into them, it reminds me of a developer joke that when you're creating code, when you're working on code, think of it, the next person who's going to maintain on it, as a psychotic axe murderer who knows where you live.
There you go.
Yep.
Good way to end it.
Yeah.
So it's funny. The very first pattern I ever learned, and I actually looked up before we got started today, and it has the funniest name. It's from the Craig Lerman book on object-oriented programming. It's called Pure Fabrication. And it's funny because now it actually, in the reference, it says basically it's a service. But I always thought that was kind of funny because any kind of class you learn, you're like, don't ever invent anything. So pure fabrication is a pattern. It's the idea that I'm going to invent something to solve this specific problem because there's nothing else that makes sense, aka a service or manager.
I feel like we could. I mean, we tried to concentrate on patterns, but there's a lot left over in terms of like just inheritance and languages. We didn't really even get into JavaScript. Patterns in JavaScript's a different animal. It's not really an object-oriented language. I mean, that's my assertion. It's not.
I definitely think there's some future discussion just on the concept of abstraction versus composition.
Yeah.
Just as that, or even like Becky said, the original construct of encapsulation and the other stuff, and like
how it's failed us. That's what I say.
Or maybe we're using it wrong.
Maybe
it's not a failure. We just try to over-engineer
it all.
Yeah. So those are our thoughts. So you, listener, what's your take on design patterns? Are they the foundation of your entire architecture, or do they just get in your way and you try and avoid them altogether? We'd love to know. Please leave a comment on the website, staticvoidpodcast.com, or send an email to comments@staticvoidpodcast.com. And as always, if you have a topic you'd like us to discuss on the show, please feel free to let us know through those same channels. For instance, was there something on this show that you wish we'd gone deeper on, as Chris just mentioned? We want to make sure that we're talking about the things that you want to hear about. So, Chris, Todd, thanks for the chat.
Yep, it was awesome.
Yeah, thank you.
And thank you, listener, for spending the time with us. We hope that you enjoyed it, and we look forward to seeing you next time on the Static Void Podcast. Woo.
All right. Inheritance sucks.
Yes, it does.
Screw inheritance.
Inheritance is evil. So I did get some feedback when at the user group, at the Code Camp. People that came up to me and said they were listening to the Static Void Podcast. Yeah. A lot of them said they'd like to see us talk a little more about .NET.
That's funny.
They're like, I love what you're doing, but you don't talk about .NET a whole lot.
I don't use .NET. Not interesting.
I had a conversation with someone on the way I explained it. When I did my talk, I'm like, 80% of the code I write today is JavaScript. 20% is C#, and all I'm really doing in C# is Web API stuff. I'm going to get some data, going to serialize to JSON, the bulk of my work. And they're like, well, what are you doing in C#? I'm like, it's just plumbing. It's just data access. My real work is trying to figure out how to make JavaScript work. And
I just started on a side project using Node, so now there's no C# or
well, there was one guy in there, he was saying, like, well, I just use Node on the server, too. And I'm like, well, there's an argument to that because you're using the same language.
You know, I agree about that, and I'll tell you, I've been thinking about this quite a bit. In fact, you saw that I sort of hijacked the panel by asking how many of you people care about what's being announced at Build, because while there's geek, look, don't get me wrong, and I'm not just saying this because we're live. The fact of the matter is, I am excited just as a tech like geekiness of the Xbox One dev mode and being able to write apps for it, and HoloLens, and thinking that I could have one app that works all those places. I'll be honest, that's exciting. Then I think about, well, I'm going to go to work Monday morning, and none of that's going to apply. Yeah. Because when does it go to work?
Yeah.
The interesting thing that's becoming more and more pronounced for me is that C# is awesome. .NET is losing its appeal. C# is like almost gaining appeal. Not really, but it is holding steady. For me, personally. I'm not making a comment on the industry as a whole. Just C# for me is an amazing language. It's awesome. I love it. .NET is losing its appeal.
What do you use C# for?
I don't know. Web API on the server.
See, but that's it, right? Yeah. Isn't that where it's coming to?
Yeah, of course.
And
it's a server language.
Now, okay. 4 years from now, will that be Node?
Could be something else.
Server? I guess.
I'm not saying it could. It could be something else. I'll tell you guys something funny that I decided to learn Haskell.
Mm-hmm.
Trying to implement a web API with it, and it's fun actually. I actually really like. Look, I'm not good at it, but I like the idea of no state, none. Everything's pure. It's taking some readjusting of the brain.
Yeah. Well, and who was it? Was it Todd? Were we talking about it? Yeah, I think we were about.
Service fabric?
No. I'm loving unidirectional data flow. So we've been doing Flux on some of our projects with.
It comes from somebody else with that. You weren't talking to me about it.
Yeah, it comes from the React world, but but it's gaining popularity more and more. Angular 2 is embracing it, where you have your like source of data, and whenever anything changes, it emits events, and people who are consumers who are interested go and get their data, refresh it, and if they want to change it, they make requests, right? Like it's the C2RS,
yeah,
and they go back down to the bottom, and then it goes back up again. So never are you writing down, and it just makes everything simpler.
Yeah, there definitely is some validity to that. So I think, Chris, you're on to something. I actually think, and we talked a little bit last time, the concept of service fabric, or that concept of what I call the MTS concept, the idea of I have a host environment and I'm writing components that plug in and do individual things, I think that's where we're going to get to.
Yeah.
Because that's where we were back in 2000 in the Microsoft world. You were writing server code. You were writing that same type of. You weren't building controllers. You were writing these components, and they did whatever they needed to do.
I don't mean to oversimplify it, but it's loose coupling, right?
Yes,
it is.
And that's why I find myself relying more and more on eventing, both at the lower level design and higher level design, because that's my go-to implementation for loose coupling.
It's a whole other Martin Fowler book, event-driven programming. I almost laugh. I've read it years ago, and I'm like, so we invented Node. That's exactly what it is. All about eventing. And some kind of event happens somewhere in the system.
Right.
Someone wakes up. I mean, BizTalk is the quintessential example of this.
Yes.
He gets notified and says, I need to run this workflow now. So I'm going to run this workflow, and when I'm done, I'm going to return something that says I'm done.
Well, the magic is you have no suppositions. You cannot rely on state because you have no idea how you just got called. You just get kicked in the ass.
You accept something process it, and when you're done, you write it out somewhere, and then you start over again. Yeah. And it's funny, things like BizTalk actually do have a concept of state, because certain times you can sync and do other things.
Sure.
Because for complex business transactions, you need that level of state.
Well, but eventing, an event-driven pattern doesn't necessarily mean no state, right? Like it's
more a sequence of steps or operations.
Right. You can react to an
operation. You might save state, but
exactly. But in the next event that gets triggered or the next thing that gets triggered as a result of your event saying I'm done or whatever, the very first thing it does is say go to this source of truth, grab the state, right? Grab whatever's data is there, whether it's data or state, irrelevant, but grab that, start working with it, and then maybe at the end save it, right?
I used to love Windows Workflow, but never went anywhere. But that was that concept. That concept of this of thinking in that higher level of this. I'm defining this workflow, and each piece is a service that gets called.
Because ultimately everything is a workflow. It's a state machine.
It's a workflow with services. It's a new pattern. Workflow with services.
But the workflow API was just it was
the wrong. There were other ones better out there that unfortunately cost money.
Yeah.
But I ultimately think that's where we get to. Eventually, you're going to go somewhere, and you're going to probably be in Azure.
You're writing workflows. Yeah.
And you're going to be plugging in components. You're going to build these components, and somewhere you'll connect these dots to say, all right, when this operation happens, now I'll call this other thing, and
and then business people will be developers, and pigs will fly, and
yes. No, we'll still exist.
Dogs and cats will get married.
We'll be the only people know how to use keyboards.
No, everybody's going to be a coder, man. Haven't you heard?
Yeah, Minecraft.
You just need a workflow engine in Minecraft.
There's one already there. That's how it works, man. You get blocks, you can light a switch, and it'll go over here, it'll do something, and light something else. You can make it work, man. It's built right in. Nice. It's object-oriented programming, block-oriented programming.
All right, cool. Let's see if we can get off before 1 a.m.
All right, be safe, this sucker.
Awesome. This is awesome. So rather than producing previous episodes, we recorded a new one. So now I need a break. I need to actually produce. Chris, you want to get together tomorrow and we can I can show you how I get started. I'll get started on the build one.
Okay.
Just stitch them all together and just show you my process. Not saying I know what I'm doing. I can just show you my process. You can take that for what it is.
And you just bring in. Is this gonna be a podcast? How we edit the podcast?
You just bring in the FLAC files and that's it, right?
Yeah, just import them, sync them up, and then But I can show you a couple tricks, tips.
And you still want FLAC files, right?
Yeah.
So here's the deal. Like to the point about talking about .NET, what would we talk about? would we talk about Azure? Because to be honest, do you think there's interest? Do you think developers want to know more about? And I don't mean the infrastructure as a service. To me, that's great. That's
I
rack
know
space
there's
to
certain
me.
things I'm interested in, but I'm not ready to talk about them because I need to go figure them out myself.
Yeah.
The
Azure
whole service
overwhelmed.
fabric is that concept is something that's interesting to me.
Yeah.
Whenever I hear about Azure or I think about talking about Azure, the only thing I want to talk about is how overwhelmed I am with the monstrosity that's Azure and how many options I have. And
But is that different if you go to Amazon?
I don't think so. I mean, but now Amazon does some things better, I'm sure, and I think I think that's a fact.
No, but in this show, we're talking about design patterns. We're talking about low level and developers
we
having
weren't-
a hard enough time picking what design patterns to use and when.
Design patterns you can implement in Java. Like, who cares?
Yeah.
No, but I
It's
mean,
not a
let
front-end
alone
thing.
like how to stitch all these things together: Service Fabric and mobile services and app services, and I don't even know what they are, but
Yeah.
right, like what's a web app? What's a
Web apps are cool, man. Like, so I'm working on this little side project.
I assume it's all cool. That's my point. Like,
And,
what do I choose? How do I do it?
Well, and does it make sense for you? Like for me, I have a specific set of use cases. I specifically chose a new job because these are the things we have to solve. That makes sense for what we're trying to solve. If you're in the enterprise, you may not really need to know those information.
Yeah.
And more than likely, by the time you do, it's going to change.
Well, here's the other thing. Now, is there a show? Because let's just say we start. I mean, maybe this is the problem. Maybe people need to learn it. Let's just say that people that we do like the show on Azure stuff. You know what happens? A lot of people. Well, I can't use this at work. They're not going to let me use it at work.
Mm-hmm.
And so, like, I'm trying this out on my own for the very reason that they're not interested at work. So it's like I want to know how this works. So, like, here's a website, right? And so far, I've been committed to only using static files. I don't know if I'm going to. I'm still feeling out whether I'm going to stick to that commitment, because then these don't even have to be in a web app. These can just go into either tables. Like, what is it? I think you could throw them in like blob storage and. Or you can do it on AWS too. You can throw them in S3 and it's a website. But then I also have this API in Node, and whenever I check in to the production branch, it's going out to Azure, and I love it. I love the workflow. I absolutely love it. And if I was at a real job, I wouldn't just have the two branches, right? I'd have like staging, production. There would be a whole. You got to, as you get bigger as a team and as an organization, I'd have to think about that flow. But since it's just me, I don't think about it. I just say, okay, I'm working in master, or I'm working somewhere else and getting the master, and then, okay, I'm ready for this to get out there.
Mm-hmm.
And just tonight, like just the stuff I did tonight, and it's like, bam, it just works. It's just done. But what I haven't done yet, I want to add tests to the mix so that if it fails the test, it doesn't deploy.
Yeah.
Just little stuff like that, and I feel like
yeah. Well,
like who's doing it? Are you doing it? Are you doing stuff like this?
we're getting there. That's my ideal state.
I'm going to have to.
We are. Well, I mean, I think it's pretty easy to get to run unit tests, and if they fail, then the build fails, right? But then the whole orchestration of like deploy to a server, which we're doing that. We're doing continuous deployment. This is like internal in a LAN. Deploy to a server, but then go and run your functional tests against that deployment. Your smoke test, your functional test, your acceptance test, whatever you want to call them.
Right.
Run your end-to-end tests against that deployment. The tests that decide, is this a valid deployment? Not necessarily like, does the logic work or whatever.
Something else could have gone wrong.
Did the fundamental, just like baseline deployment, like can you even hit the app? Can you hit the main pages? And then like run through like the top 10 most important workflows or whatever. Just like a sanity check, smoke test, right? And if
Well,
they're
you could
all
even run a load test against it.
or a load
It's
test,
something.
right.
Did
But
we do something that made it slow?
Exactly. But the point is deploy and test the deployment itself,
Sure,
the
right.
working, running application end to end, which you hadn't done up to that point because you couldn't, because you didn't have an environment to do that. And then the result of that is the result of the build. By that time, the build has already completed, right? The artifacts have already been built, and something has changed in an environment as a result of this build. So it's not as easy as like rolling back what you deployed. But then you go back and you do what, right? You mark the build as this was a successful build, this was a failed deploy, this is a failed smoke test, whatever, right?
So what does any of that really have to do with Azure?
I'm trying to figure out what
That's all DevOps stuff you're talking
yeah,
about.
like what are the
It's all
topics?
DevOps, yeah.
I mean, Azure.
None of it's specific to Azure.
Yeah. So I guess it really depends what you mean by cloud. To me, cloud is, like I said, it's the execution code in, we're talking about event-driven design, event-driven ways.
Okay, so the C# show, is that people will look at that and say, hey, you talked about .NET?
Yeah, I think so.
Okay.
Sure, yeah, sure.
I mean, we could probably do things on like just like, again, it's kind of hard sometimes with not jumping slides. Like Visual Studio, they mentioned that 2015 is coming. What does that mean to a developer? 2015 is coming.
Well, 15, which will probably be called 2017, which will be awesome because then in 2018 we'll have 16.
Yes.
Although as we start to get further away, people will get less confused again. It's just we're in this horrible place where the version numbers are keeping up with the years.
And they had to skip 13.
And then they skipped 13, which didn't help.
At 9. Don't forget, he's got to skip 9 too.
Did they skip 9? Oh yeah, I guess right, because they brought everything to be 10 for some reason. All right. Anyways, so
I mean, when you come,
I appreciate the feedback, though. I appreciate it. What I'm curious about is, what do we talk about?
When we do the user group on Thursday, there's going to be a lot of the same people there. We can ask, like, hey, what would you like to hear? Like, what do you? Because remember, some of the stuff we can't really do easily on our podcast. Maybe it is a presentation that eventually gets done.
Yeah.
So, but everyone liked the idea. They liked our approach of being very practical and very down to earth, and not being just like I said, like the way that we described it. It's just three people having a conversation. It's not meant to be we're gonna solve all your problems.
Yeah. We're talking. If you want to listen in, that's up to you, man.
And we were arguing this time.
I know. We finally got some, I wouldn't really call it disagreement, but we got some more interesting and
passionate debate.
Yeah. I don't know, man. I think I've told you this. I went to the Richmond Code Camp years ago, and what's his name? There was a guy there. Yeah, he was moderating in open spaces, and he would just take the opposing side. You couldn't tell at the time, but I found out later that he just took the opposing side. I mean, you might call it devil's advocate, but it was so much more than that. Like, he argued it.
There is a whole
debate team,
tactic, right? Yes.
Yeah.
It's called like a mock trialing, almost in a way. Like you take the other side to break down the arguments, and
Yep.
You learn that in debate classes.
He just did it, and it was awesome. It was great.
Well, it's very easy to destroy things or throw darts at it.
Well, yeah, but I mean to make it constructive, and
yes,
not just,
and in a way that it actually sounds like it's not fake.
Yeah,
it came across as real.
Yeah.
Okay, so we're gonna shoot for Sunday again, and what are we gonna do?
Oh my god.
Or we want to think about it.
Let's give it a couple of days. Let's talk about it on Thursday.
Yes, Chris, you all ready to
go? Sure.
For what?
You're doing on Thursday night?
Yeah, I got to do some work tomorrow, but otherwise.
But you already had this in the can.
Are you going to talk about Azure and your social coding talk?
Well, he can demonstrate for GitHub, right? It's all about Git, your social programming.
So, it's a little bit about Git and how I've learned to solve problems that I think a lot of people solve by deleting the repo and pulling it down.
Mm-hmm.
And I'm not saying that you shouldn't do that in certain cases, but I am saying that you shouldn't do it when I don't think you should strive for that when the answer is, let me copy some code out somewhere, pull the repo down, and then use beyond compare to get back to where I was. I feel like, okay, that's a lot of work.
Yeah.
And sometimes it's because there's ways the tool can help you, even though it's like arcane magic figuring it out, which I hate. And I'm still fine with that. I still hate the fact that it's knowing arcane commands instead of being able to just say what you want to do.
Have you found your Magic UI yet?
No, there isn't one, except maybe I haven't gotten to play with it a whole lot. There's a new one that just got released that I have not gotten to play with. And see, it's not so much about it's
What?
like it's
Kraken?
called Get Kraken, yeah.
Yeah, it's not that great.
Well, I mean, I don't know that it's not that great. Like, what if I try to rebase with it? Does it make
No,
sense?
I used it extensively. It's
See,
not that great.
I feel like the metaphors are there. They just
Not-
don't need to be so hard to access.
Not really. Well,
And,
even
no,
just
I'm not
generally
talking Get
speaking.
Kraken. I'm talking
Yeah.
like
Have
the
you
metaphor.
ever used, source tree?
I've
wondered
heard that's-
we've
yeah, other
used at
people
work.
said it's pretty good. Yeah, I just don't have time to try them all.
Sounds like you need a job that's dedicated to this work.
Yeah. But, like, for example, just some of the concepts of, well, the branch that I was working on has moved ahead of me. What should I do?
Yeah.
That's a concept. And the fact that you have to memorize or at least have some notes of the command that implements the concept is what I don't like.
Yeah.
I like the concept. I want the concept. So,
Here's something to think about, and I'm not sure how we do it in a conversation. But about this source control organization or project organization. Like even thinking about branches, but even like, okay, like why do I have a project that does X, Y, and Z? Why do I have an assembly that does this for that? Again, I don't know how we talk about it without pictures, but I do know a lot of places you start out sort of one approach, and over time you start becoming more and more brittle.
yeah.
So it seems like there's even design patterns around how you organize your code in a source control environment.
So basically, what I was going to talk about is some of it is about Git and these metaphors for look, we can all do Git init, and we can make a few commits, and we might even be able to merge a few branches. But the problem starts when 3 people start working together. In fact, I would even argue that, so in order to prepare for this, some of it I just worked with a friend, and we had problems.
That's the definition of social coding, right?
Yeah, like just the fact that he would
Nice
say to
one,
me,
Josh.
I don't know what to do. I don't know what, I'm behind master. What do I do? And so, well, here's what I think you should do, and try not to make the answer give up, or you went ahead and I went sideways. How do we bring this back together, right? Obviously, conflicts are going to happen. That's one thing everybody always asks: how do you resolve conflicts? So we'll show that. Show what the Visual Studio tool can do. Show what you can do at command line. I like showing GitHub Desktop because I kind of like it, but I will admit there are others. It's just I don't have time to play with them all.
Well, you can have a slider or something that says, here's some other ones out there you might want to look at.
Yeah, but then what I do like, what I have been doing is, I've been playing with this stuff on GitHub. So that's the social coding part. Is like, okay, so now you know Git, but what GitHub offers you is the whole social experience with the issues, and I'm talking, going through like, look, you can file issues, and then look how you link stuff together. And I even I've done the same thing over on Visual Studio Team Services, just because people ask. I wonder if people use that. Like,
I have.
Yeah.
Mm-hmm.
I mean, it's
More-
cool. It's cool. You can like have conversations, a code review right there. It's nice.
More about just TFS in the cloud than start with the online. Just
Yeah.
because we needed some environment for people to check coding together. And then
Right. Well, and it works, and you can comment. You can have like code review right there. You can write comments on lines.
in our case, it was just TFS. Our TFS server was just sitting on Azure.
Yeah. Oh, okay. You just put TFS in Azure instead of using VSTS.
Mm-hmm.
I mean, VSTS is cool. It's just so big that I think it scares people away, and it doesn't have all the features GitHub has. But then it has other things. Like from right there, you can have your build artifacts, and it's like everything, right? You can either go best of breed and have 4 different products or 6 different products, or you can just say, well, I'll just go with Microsoft solution, and everything's not best of breed.
I can only tell you about this situation, but in 95% of the situations I've worked in, most people don't have builds. It's just a place to put source, and then they have some other process that figures out the build later. That's the real world.
I know. That's
I
what
wrote,
said
I wrote
too.
a
I hate it.
15-page document and built them in MSI, and they still couldn't do it. They
Yeah.
still had problems. And the MSI had everything, like, literally, it's like, you need to get this code out of TFS. You need to make this, and this change because when you deploy it to the server, we didn't have that information. Like, literally, there's big blocks. Here, in webconfig, change this connection string. Here, over here, change this. Here, in this case, we had to have 2 different servers. So, like, here's the MSI that installs the REST API behind the firewall. Here's the one that installs the website and the REST stuff for the front end. And it still wasn't enough. And even now, when they come back to us, that's one of the first, like, how do we deploy this? It's like, couldn't make it any simpler.
No.
You get the code, you compile it, and you run the MSI.
That's why I want to get rid of them and just auto deploy. Just want to DevOps all the things.
When you're a consultant, you try to avoid deployment. You want to be as far away from that as you possibly can. You just want to get your stuff in and say, "Pay me." That's that's your problem to worry about. Because it's a little more, it's more for politics and other problems. It's a human being problem, not a technology problem. The one place I consulted at, they still actually have to sign forms when they go to put something in, and it's funny, they're running around. Okay, was this person out of the meeting so we can get them to sign this form? We need to sign this form.
Yeah.
That's even the most simplest, like just pulling it for a proc.
Release the build.
Yeah.
Approved.
The approval workflow is not even automated.
You should check out Electric Flow. It's pretty cool.
Nice glasses.
What is that? What is
It's a build orchestration platform, basically. You can tie in Git or TFS or Jenkins or whatever, and it's just kind of
chickens.
You define the workflow, the process, and then you kind of plug in the pieces that go into it separately from the process. It's interesting.
I think, as a nutshell, and then we should go to bed. As an industry, we are still learning we are still crawling, and we're just starting to crawl.
Yeah, certainly. Is there a way to?
I really can't take you serious with these glasses on.
You don't need to take me seriously. Is there a way to put an overlay on the screen in Google Hangouts? I just want to put. So I started a Jabber room. That might be cool. Like as we get live viewers, if we can put something, because people like come in late or whatever. I just want to put some text on the screen to say like join the.
I thought we had something.
Static
one
Void
day.
podcast.
We definitely have things that you put you in.
An overlay? Yeah, right? What was that?
It wasn't in Google Effects. I'm turning it on. There's randomizer. It's
clearly not the glasses effect.
No, there was. Was randomized. Like Chris has it now. He put something behind him. How did you get that again? Oh, it's that headwear. I guess it's underneath.
It's under Google Effects. So the other thing that's like people supposedly.
There you go.
If you go to the right link,
you can't do it a custom.
You can do Q&A. So there's like 2 ways to watch a Hangout. There's YouTube, and then there's also going to the Hangout but not joining the Hangout. It's
how?
I don't know. Whatever Scott Hanselman does every week for Live ASP.NET.
We've talked about that before.
They don't show you links up there. See, I can't look at any of this stuff.
Maybe if we ask Fritz.
I'm gonna have to start the Hangout, or actually ask Galloway or someone because
they should be able to tell us. There must be something, unless there's a pay service way of doing it too.
I don't think it's paid. I'm just gonna have to start the Hangout. That's what it is.
You just start to hang out with Hanselman.
No, what I mean is see, I can't do anything.
Oh, here you go. Custom overlay.
What'd you do?
Custom upload.
What happens if you click the Q&A button? What does it say? This feature
it's in the Hangout toolbox. It says it's disabled.
In the toolbox?
And you can't do anything?
Right.
Well, anyways.
Well, I think you have to start it before you start broadcasting. I've done it before. I started it before. You have to do it before you start broadcasting. Where?
I don't see it here. Oh, there's custom overlay. There you go. There's no overlay selected. And then you have to select one. Ooh.
Thumbnail logo.
There you go. I didn't see you. I see setting for your podcast.
So, okay. So maybe if you do if you, and then I can flip it. Oh, you can have either the lower third or the overlay. Okay.
But I don't see your face now.
Well, yeah, right. But I'm wondering if maybe you do, maybe, let me see, paint.net and do a transparent background. Maybe that goes.
Oh, like the one Chris has, maybe?
Yeah.
Maybe. I don't know. That sounds like something you can work
Static
on.
Void podcast talking right now.
Just put a head. Just put it in your
Yes.
picture. You'll move, but your picture will always be there. There you go. You can create a table with our 3 heads sitting there. And then this person. Alright, my file's uploaded. You gentlemen think about what you want to talk about. Waiting for Sunday.
How about I will produce and you figure out topics?
Okay.
I'm going to spend the rest of the week producing the 5 shows in the can right now.
You could talk about why we don't talk about .NET.
There we go. Sure. Oh, it's legitimate, right? I mean,
Yeah,
it's
let's talk about the our opinion of the relevancy of is that relevant? And what does it mean?
there you go. Sounds like a show.
Yeah.
Or we
Roger.
can just do Satya impressions the entire time.
I am jumping off. You have a good
All right.
evening.
Yeah.
Chris and
Talk to you guys
Jess
later.
will see you on Thursday.
All right. Later.
Yeah.